Audio Jungle.
This is step-by-step revision series, and differentiation is the topic which we are going through, and this is part 3. If you have watched part 1 and part 2, then this is part 3 for you. If you have not yet gone through part 1 and 2, better you should go through those basics and you should understand that one, and then you should come back to this part 3. So in this part we will be in previous two parts we have done this differentiation, how we are differentiating powers of x and finding gradient, finding maximum point and minimum point. Now we'll be going through a little complex questions related to maxima and minima. So this is question 1 which we have chosen. Find the coordinates of the turning points. So coordinates of the turning points are required of each of the following curves. Determine the nature. So nature of the turning points is also required. So first we will find the turning points. To find the turning points we are finding derivative and putting it equal to 0. So dy over dx will be equal to derivative of this one will be 2, and then we will be pulling this 3 and x raised to power 3 minus 1, then this one will be plus 18 and we'll pull 2 and x raised to power 2 minus 1 and plus 48, and derivative of x will be 1 minus derivative of constant is 0, so we're putting 0, and we can write this one as 2 into 3 will be 6x squared plus 36x plus 48, and this will be our dy by dx. And now we can put dy by dx is equal to 0 for the turning points. So our equation will be this one, and 6 we can take common, so 6 into x squared plus 6x plus 8 is equal to 0, and this equation 6 is not equal to 0, so this implies x squared plus 6x plus 8 is equal to 0. This is quadratic equation which we can solve with the calculator. So mod 5(3), and the coefficient of x squared is 1, so we'll feed value 1. Coefficient of x is 6, so we'll enter 6. Then 8 value is constant, and we will get x1 as minus 2 and x2 as minus 4. So minus 2 and minus 4. So x is equal to minus 2 and x is equal to minus 4. You can show your working also, like for example x plus 2 and x minus 4 is equal to 0, and then you can write this. And then what you are doing, like for example these are two values and which we will have to replace in this given equation. So replacing in this one, y will be equal to, so our equation will be, these are two values, so at x is equal to minus 2, y will be equal to 2 into minus 2 cube plus 18 into x minus 2 squared plus 48 into minus 2 minus 10. So instead of replacing this manually, what we can do, we can use calculator. So we will type this equation 2 and x cube, so alpha this one and cube will be this, and then we are writing plus 18 x squared, so alpha this one and squared plus 48 and x, so 48 and alpha with this x and minus 10. So this is our y value, and we can solve this when calculate this when x is equal to minus 2. So if we replace minus 2 we'll get minus 50. So at this one, y will be equal to minus 50. So our point will be minus 2 and minus 50. So this will be our point. And the second point which we can find at x is equal to this minus 4. So we'll replace minus 4, and the same equation, this implies y will be equal to, if we replace the same equation, if we calculate this, for x is equal to minus 4, so this minus 4 will be giving us minus 42. So our point will become as minus 4 this x value and minus 42 this value. So these are the 2 points which we got. These are the extreme points like minimum and maximum, but now we have to find the nature of these 2 points, determine the nature of each turning point. So these are the 2 turning points of this equation. Now we have to find the nature of these 2 turning points. To find the nature of these 2 turning points, again what we can do, we can use graph paper, and this is how I will explain on this graph paper. So like for example, this is the point. We will check first this minus 2 and minus 50. So this is the point. So what we can do for this point, we can use this calculator where we have already written this equation. So we can take 2 values. One should be on the left side of minus 2, like for example we can take minus 2.5, which will be on the left of this 2, and one value we can take on the right of minus 2, which we can take minus 1, and we will check for these 2 values what are the answers of this equation. So we will calculate this equation for minus 2.5. So calculate for minus 2.5. This will be giving us this number, which is minus 48.75. And if we calculate now for minus 1, calculate for minus 1, we will be getting minus 42. So I'm using calculator for your convenience, and it will be time saving also in exam. So now we got left side value and right side value of this minus 2. If we check, if we compare this minus 50 and these 2 values, y values, minus 50 will be lower than these 2 values. So because this is negative, so minus 50 is lesser as compared to this. It means this point is at the lower level, like this one at this point. So this is basically the minimum point. If this value is lesser than these 2 values, then our point will be minimum. If this value is more than these 2 values, then our point will be maximum. This is what you will have to keep in mind. Now if we check the second point, and our second point is minus basically 4 and minus 42. This is the second point. Now we can check for second point. We can take 2 values similarly on the left, one value on the left of minus 4 and one value on the right of minus 4. So one value we can take for minus 4.5, and the other value on the right we can take minus 3. You can take other different values also, but I have taken these values. So the same equation I'll be using for this value, minus 4.5. So calculate minus 4.5 value. This will be giving us minus 43.75. And if we calculate for minus 3, calculate for minus 3, this will give us minus 46. So this is the point which we got, and these two values, if we compare with minus 42, so this is higher value because this is negative, so you will have to be careful. This is the higher value as compared to this. It means if we plot this curve, and if I move this a little further, so if we plot this curve, it will be opening downward like this one. So this point minus 4 and minus 42 will be above, and these points will be lower side on these two sides. So this point is maximum point or maxima. So this is maximum point and this is minimum point. This is how we can identify these points, and here we can give our detail, and we have identified this point as minimum point, and this one as maximum point. And I have separately explained you on the graph why we have taken and how we have taken these points. Hopefully you understood this. Sometime in exam they are giving word problems in which we are using differentiation. For example, an object is thrown up into the air, its height s meters above the ground after t seconds. So this is height, this is time, is given by this equation. Work out ds by dt. So our first task is to calculate this ds by dt. So a part we can write s is equal to 2 plus 4t minus 5t squared, and then we can write ds by dt. ds by dt means derivative of s with respect to t, constant derivative will be 0, plus 4t derivative will be 4, and minus 5 into 2 we can pull first, and t raised by 2 minus 1. So this will be equal to 0, and this will be 4, basically 4 and minus 10 t. So this will be our ds by dt, which basically this a part we have done. Now b part, find the maximum height. Find the maximum height the object reaches. So we know at maximum height gradient will be 0. So at maximum height, ds by dt will be equal to 0. So we'll be putting this 4 minus 10t is equal to 0. This implies, we'll have to move page a little above. So this implies 10t is equal to 4, and t will be equal to 4 over 10, which is equal to, we can use calculator to find this. This will be 4 divided by 10 will be equal to 0.4. So 0.4 will be this value, and now this value of t we will be replacing in this given equation, which is s is equal to 2 plus 4t minus 4t square, and this value we will replace. So this will be 2 plus 4 into 0.4 minus 4 into 0.4 whole square, and we can use this to 2 plus 4 into 0.4 and minus 4 into 0.4 whole squared. This will be equal to 2.96. Basically we have done a small mistake. This is not 4t square, this is 5t square. So this will be 5 over here, and this one also 5 over here. And now if we calculate this with 5, so we'll be getting as 2.8. so our answer will be 2.8. so height will be s will be equal to 2.8 meters. So this will be our answer. So what we have done, if I quickly go through this question again so that you can understand the word problem. A part is just straightforward. We just have to take derivative with respect to t, which we have done in 2 steps. Then they are saying find the maximum height. For the maximum height, this derivative should be equal to 0, because we know that at maximum point or minimum point derivative is 0. So we are putting derivative equal to 0, and after putting derivative equal to 0, t value we got is 0.4. It means that after 0.4 seconds the object which we have thrown in air will be at maximum height. So this time we are putting in this given equation and we are getting the maximum height, which is 2.8 meters. Hopefully you understood each and everything. This series we have completed with 3 videos, and I'll be waiting for your comments. So in 3 parts we have covered differentiation powers of x and gradient, and then maximum point and minimum point, and how to find the nature of points, and plus we have done the word problem related to the derivation also. And if you like the video, don't forget to subscribe Maths TV and recommend this channel to your friends. Also introduce this channel to your respected teachers. Thank you very much for watching. See you. Take care. Bye.